This is the video for lesson 4.4. In this lesson we're going to be using the side congruence postulate. Go ahead and write the learning target, please. I can prove triangles congruent using side congruence. If you don't have a pencil, please switch to a pencil now. It is required for all work done in the geometry class. And our first thing that we want to take a look at is the postulate, the side postulate. So as we work through our triangles unit, we're going to have several different postulates. This first one is going to be the side congruence postulate. And it states that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. And in our first example, we're going to prove that triangle JKL is congruent to triangle MLN. And when they say prove, generally that means to make some kind of proof, kind of a formal proof, second, with two columns in it. And we're just going to make ours really casual, not a super formal proof. So what they want us to do is just say which sides are congruent, and that, to kind of show that the two triangles are the exact same triangles. So congruent means they are the exact same. So if you notice, there's a tick mark here with just one tick mark. This side here also has one tick mark. And if we look at the names of the triangles, that side here is called JK, and those are the first two letters listed in the name. And then the letters ML are the first two letters listed in the name of the triangle here as well. So let's go ahead and write sort of a semi-formal proof. So JK, side JK is congruent to side ML. Okay, so that's one side. And now we need to find the other two sides to mention that they are congruent. So I see two tick marks here, which means it's the same length as this side LN. All right, so we can list KL is congruent to LN in the other triangle, and that's two sides. Now we just need that third side to be the same length, and I see that there are three tick marks on JL and three tick marks on MN, and therefore those two sides are also congruent. So JL is congruent to MN, okay, and that's the third side. So we have everything we need to use the side congruence postulate. And what I can do here is say, therefore, okay, these three little dots that are in the shape of a triangle, therefore triangle JKL is congruent to triangle MLN. So you really don't have to do, too much, but you do need to mention that there are three sides that are congruent, and you can recognize that by the number of tick marks that each side has. There are 6 problems in the On Your Own practice section, and I'd like to do a few of them with you, and then you'll be required to do the others. It does say here that we want to decide whether the congruent statement is true and explain our reasoning. So in problem number 1, it says that triangle ABD is congruent to triangle CDB. And we have to decide if that's true. Well, let's take a look at the first two letters. The first two letters are AB, and side AB has one tick mark. And the first two letters in the second triangle named here are CD, and the tick mark, there's only one tick mark on that side, so we're doing well so far. That's one side that we see as congruent. And then if we can take a look at the second two letters, BD, BD and then also DB listed here. So that means that this side of the two triangles is congruent to each other, and we do know that they are congruent because what do we know about something that looks like this? BD is congruent to BD. Well, that means that it's reflexive, and therefore congruent to itself. So we can put 3 tick marks on that side. Okay, so we want to remember that we have the reflexive property to be able to do that. And then the last two letters that we would be writing down are the ones that have 2 tick marks on them. So we have 3 sides with the same length in each triangle, and therefore these are congruent triangles. And we already have listed one side, this side right here that we said was reflexive. The other two sides, AB and CD, as well as AD and BC. Okay, and so we can say yes, that they are congruent. All right, and here's our reasoning. Our reasoning is just showing that the three sides are congruent. All right, let's take a look at number 2 then. In number 2, we have a couple of triangles that we have named, and they have named. Congruent sides would be XW and WZ. Let's see if that's true. XW has 6 and WZ has 6, so we can write that down. Let's go ahead and write it down, and we'll determine if it's congruent triangles in just a moment. So there's the first side. And then how about WY and ZY? Those are the next two letters. So WY right here, and ZY is this length right here, and that's 9. Okay, so that means that WY is not congruent to ZY, and therefore this triangle on the left is not congruent to the triangle on the right, and the reason is because the way they have it named. The letters are not in the correct order. Had the name been ZWY here, then we could say that those are congruent. So therefore XWY, I should probably draw a triangle here, is not congruent to triangle WZY. Okay, so the two triangles that they have named, the way they have them named, do not represent congruent triangles. So there's a naming problem here. Named incorrectly. Because if you look at the picture, you could easily say that those are congruent triangles. However, because of the way they have them named, we cannot say they are congruent. So be careful with that when you're looking at any triangles. Make sure the names of the triangles are actually correct. All right, in problem 3, they're asking us to check and see if RST, here's RS, that's 2 tick marks, is congruent to VUT, and VU has 2 tick marks as well. And then how about ST, that's 1 tick mark, is congruent to UT, and that has 1 tick mark. So I think we're in good shape. Notice that they do not use this line at all. We're not looking at the big triangles in this diagram. We're looking at this triangle as well as this triangle to verify if they are congruent triangles, and they are. So we can write the fact that RS is congruent to VU and ST is congruent to UT, and then the last one would be RT is congruent to VT, and therefore remember these 3 dots that I'm drawing here mean that the word therefore is being used. Okay, so we've explained what we needed to explain. Therefore triangle RST is congruent to triangle VUT. So I'd like you to finish up on your own sections with numbers 4, 5, and 6. I will give you a hint that there is one problem that is not congruent. Okay, so that side does not work for one of the 3 that you still have to finish. On the back of your note sheet, we do need to use the side congruence postulate to show that triangle ABC is congruent to triangle CDE. And in this part of the lesson, we're going to be using the distance formula, which we've used before. And it's nice because in the diagram here, they've given us the X and Y values. So what we need to do is list the corresponding sides, and we can do that according to the names here of the triangle. So AB should correspond with CD, and BC should correspond with DE. So we're looking to find out by using the distance formula, does side AB have the same length as side CD? And does BC have the same length as DE? And then our last one will be AC, and we want to make sure that it has the same length as CE. Okay, and if those things are true, if they do have the same length, then we'll know that these two triangles in the diagram are congruent triangles. Alright, so all we have to do is we have to set up a distance formula for the side AB. Okay, so AB, here's A, this is our x value for A, and our y value, and x value for B, and our y value. So we're just going to go ahead and write in the information. So the two x values are going to be subtracted, and then we're going to square them. And we also need to be doing the same thing with our y values. Okay, and if you're using a calculator, you'll see that you are going to square -1 plus square 5, because the result of this is -1, the result of this is 5, and therefore I'm going to square both of them, add them together, and so my final answer here is going to be the square root of 26. And let's just leave it like that for right now. We're going to move on and we're going to find the length of CD, because I want to make sure if it's square root of 26, then that would give me one side that is the same in each triangle. So our x value for C and our y value for C, and then we're also going to be looking at these two values here. So I'm going to say -1 minus 4 squared plus 1 minus 0 squared, and that is going to be, well, -5 squared is 25, and 1 squared is just 1, and therefore we do have square root of 26. So it looks like these two sides are congruent, and therefore we have one side that we can say for sure is corresponding and congruent. So we have to do that 2 more times now so that we can find the matching, the other two sides that are congruent. So for BC, the side lengths, or sorry, the x and y values, -3 and -3, that's for B, and then for C we have -1 and 0. So let's write this out, -1 minus -3, and we have to square that, plus 0 minus -3. So we have to be really careful to get our negative signs where they should be and where they should not be, use them correctly. And that's going to be 2 squared plus 3 squared, and that's going to be a total of square root of 13. 4 plus 9 is 13. Okay, so let's check and see, does DE have the same length as BC? D has x and 1, so we're going to take the 4 minus 1, we're going to square that, and then we're going to have 3 minus 1, and we're going to square that. So that comes out to 3 squared plus 2 squared, and therefore that is the square root of 13 again. Alright, so now we see that two sides are congruent, so we have BC and DE that are congruent, and the first two that we had. Alright, let's take a look at the last two. So AC, this does seem like a little bit of work, but it's, just one more way for us to use the side congruence postulate. So I'm going to take -4, and I'm going to subtract -1, because I'm using the A and the C points. Okay, we're going to square that, and then my y's, 2 minus 0. Alright, let's see what we have here. It's going to be -3 squared plus 2 squared, and that is square root of 13 as well. Alright, but this is going to be comparing AC to side CE. Okay, Okay, so we have to do CE here, and C is -1, E is 1, and then we have 3, whoops, -0, okay, and that's going to be -2 squared and 3 squared. And again, that is square root of 13, and therefore we can say that AC is congruent to CE. So it looks to me like we have a long side. These two are the long sides, and then these are the shorter sides, right, of the two triangles. So we have isosceles triangles there, and that's why we had so many of the results as square root of 13, because two sides on each triangle are the same length. So it may take you a little bit of time to do your on your own problem down here, because it does take some time to think about, you know, the squaring of numbers and things like that. But go ahead and make sure that you know which sides you're comparing. AB is going to be compared to DE. So you're going to use the name of the two triangles, and I want you to show all of your work here, please, to find out if these two triangles are also congruent. So if all the three sides have the same length in each triangle, then you know for sure that they have the same, that they are exactly the same, and side congruence shows that they are the same. All right, and if you have some trouble, if you have any questions, I'll be happy to answer those in class tomorrow.